So in this class, we will solve a problem on Centroid. It's a question paper problem, July 2022 VTU. For the shaded area shown in the figure, find the value of A. So A is this distance. So that the centroid lies at point O. So centroid is here. So this is point O. So if at all the centroid has to be at point O, what should be the value of this A? So we can see, you can observe that here this is the shaded area. So the radius of this semicircular portion is 60 mm, whereas the thickness of this rectangular portion is 10 mm. So he has given that O is the centroid. So already centroid is known here. So the thing here is, in order to find the distance A, we have to proceed in the same manner. Since the centroid is defined here and the axes are defined, x-axis and y-axis, so that means this becomes the origin. Origin itself is the centroid. Now what we can do here is, we will follow the first principles method. So in the first principles method, what we do is, this rectangle and this rectangle, they are treated as simple sections. So this is section 1, this I will take it as section 2, and this semicircular portion I will take it as section 2. So be careful here. So this rectangle area, so what I do here now is, the first one is a rectangle. So what I am doing is, I am splitting this shaded area into 3 areas. 2 is another rectangle, and 3 is nothing but you can take it as a hollow semicircle. It is a hollow semicircle. So let us find out the areas of these 3, A1, A2, A3. So A1 is equal to A2 here, because these two are equal areas, rectangle areas. Now you can observe that this given figure is symmetrical about x-axis. So whatever is the above x-axis, same thing lies below the x-axis. So it is symmetrical about x-axis. So in that case, the centroid lies on the x-axis. Here, since O is the centroid he has given, it lies on y-axis also. So the areas A1 and A2 will be, the area of this rectangle is A into 10. So let us take A in millimeters and millimeters. So this is 10 times A. So this is millimeter square. So this is the area of A1, 1 and 2 both. Now area of 3, I will take it as A3, third portion. So this is A3, this is A1, this is A2. Now A3 is equal to, I have to take the area of this hollow semicircular section, which is obtained by subtracting the area of this semicircle from the area of the bigger semicircle. So area of the bigger semicircle, so I am going to take that area of the bigger semicircle as, you know that it is pi r square is the area of circle, divided by 2 becomes the area of the semicircle. So I will take the radius as r1, bigger radius as r1, minus smaller radius as r2. So pi into r2 square by 2. So you should be careful here. I am deducting the area of this small semicircle from the area of the big semicircle. So r1 here is 60 plus 10, 70. So pi into, I can take pi by 2 common, r1 square minus r2 square. So here that is pi by 2 into r1 is 70 mm minus r2 is 60 mm. So 70 square minus 60 square. So this is the area of the hollow semicircular portion. Which if you simplify that, you are going to get 70 square minus 60 square. 70 square minus 60 square is equal to into pi divided by 2. So it is a 2042 millimeter square. 2042 millimeter square. Yeah, because this thickness is 10 mm. This is given here. So these are the areas now. So once you know these areas, now the total area can be computed. Sigma AI is A1 plus A2 plus A3, which is 10A, that is 10 times A into 2, because there are two rectangles. A1 is equal to A2, area of one rectangle is 10A, area of two rectangles, that is A1 plus A2 will be this, plus 2042 is the area of that hollow semicircular portion. So your total area now becomes 20A plus 2042. So this is the total area. Now you know the formula for locating the centroid of the composite section. So you know that x bar is equal to summation ai xi divided by summation ai, and y bar is equal to summation ai yi divided by summation ai. So this is the formula to locate the centroid of a composite section, where x bar and y bar are the distances, horizontal and vertical distances of the centroid from the origin, from the origin. So here in this problem, he has given that the centroid is located here. Centroid is located here. So what we will do here is this O itself is D here. Now to find the value of A, what we have to do here is, let me try to locate the centroid about this y dash axis. So what I do here is, let y dash axis be the leftmost edge, like this here. So now from here the distance of the centroid, now this is your x bar. Now you take this as the reference axis. X bar is equal to now 10 plus 60, that is 70 mm. Now you know the value of x bar. So now what I can use this formula now. So if I use this formula, sigma ai xi. So for that, let me write the calculation form to tabular column. So serial number. So this we have done in the problems of centroid earlier videos. So figure, then you have area already we have found out it. So area in millimeter square. Then you have xi values in millimeters. Then you have ai xi value in millimeter cube. So actually this is area. Now already we have got the areas here, A1, A2, A3, 1, 2, 3 I call them. One is a rectangle whose area is 10 times A. 2 is also a rectangle whose area is 10 times A. 3 is a hollow semicircle whose area is 2042. Now if you add these three, you are going to get sigma ai, which is 20 times A plus 20. This is what we get. Now xi is the distance of the centroids of these simple sections from this y dash axis. So you take this as y dash axis. From the y dash axis, distance of centroids of these simple sections. So I will locate the centroid. So it will be here. So G1 will be here. It will locate the centroid of the same. G1 will be here. G2 will be here. G3 will be here. These are the centroids. Now, if I write the distances of these centroids from the y dash axis, they will become your xi values. So distance of G1 from y dash axis is, we can take this is a by 2, because this is a rectangle and centroid lies at the distance of a by 2. So a by 2 plus distance is 70. So 70 plus a by 2. So please be careful here. This is 70 plus a by 2. This is also 70 plus a by 2. Distance from y axis to G2. Then distance of centroid of this hollow semicircular portion from y axis is half of this time, that is 5. You can take it as 5. Now multiply these two things, a I x I, to write value here. So it becomes now here 10a into 70 plus a by 2. This is also same, 10a into 70 plus a by 2. The third one is 2042 into 5. So this value is 10210. Now if you add these three, you are going to get sigma ai xi. So let us add these three. So this is 2 times of this. So 2 times of this means 20 times a into 70 plus a by 2. Sum of these two plus 10,410. So this is the value of sigma ai xi. Now we know the value of sigma ai and we know the value of sigma ai xi also, and we know the value of x bar also. So you can see that x bar from here to here is x bar, which is 70. So let us use this formula. X bar is sigma ai xi divided by sigma ai. So that means 70 is equal to, x bar is known now, 70 mm is equal to ai xi is 20 times a into 70 plus a by 2 plus 10,210 divided by sigma ai is 20a plus 2042. 20a plus 2042. Now what we have to do is we have to cross multiply, simplify. Only one unknown is there, a is the unknown. So if you solve for a, that is the answer. Now let me cross multiply this to 70 into 20 is 1400 times a plus 2042 multiplied by 70, 142 940. 142 940. So be careful because we are getting larger values, is equal to 20 into 70 is once again 1400 a plus 20a into a by 2 is 10a square plus 10,210. So you are going to get a quadratic equation in a. You will be having two values for a. One value is admissible. Let us see. Let us simplify this now. So this 10a square, let me write the equation in this form. 10a square plus 1400a. So this 1400a, I think it gets cancels. Both sides is positive, you can cancel it. So you will be left with 10a square is equal to 142 940 minus 10210. So it is 132 730. 132 730. So therefore a square is this divided by 10, that is 13273. 13,273. Therefore a is root of that, 13,273 under root of 13,273 is 115.21. So this is the value of A, so that the centroid lies at the point O. So this is how we have to do the problem. So he has given the location of the centroid itself, and he has asked the one of the dimensions, unknown dimension. So this is how we have to do the problem. So you can, since the diagram is symmetrical about x-axis, composite section is symmetrical about x-axis, I have used the concept of x bar is equal to sigma ai xi divided by sigma ai. So this is how we have to do the problem. This is an examination problem.